Hello, my lovely viewers and my dear students. Welcome to my math distance learning class. Today we are on yet another session proceeding on with surface area of pyramids. So this is part one of the video that we are going to be discussing today, and this is a very useful topic for grade 9 and grade 10 students. So let's get started. And before we proceed further, a humble request from my side to subscribe to my channel. You can share this video with any of your relatives, friends who find it useful for grade 9 and 10. And then definitely if you have liked the video, then don't forget to like this video as well. Okay, so let me now acquaint yourself with the learning objectives for today's session. So first thing, we are going to be learning about this interesting solid, which is pyramid. And then we are going to be trying in this lesson to find the lateral surface area and the total surface area of pyramids. We'll be solving some important questions in the process for today's session. Okay, now, so when we think of pyramids, we usually think of the Great Pyramids of Egypt. So on this slide, I have put a beautiful picture of the pyramids of Giza, which are there in Egypt. And today in the session, we are going to be learning how to find the lateral surface area and the total surface area of this solid pyramid. Okay, so let me now introduce some new vocabulary terms related to pyramids that each one of you should be knowing. Let us first define what is a pyramid. So a pyramid is a solid, a three-dimensional solid, which has a base and some non-parallel lateral edges. And usually these non-parallel lateral edges, they meet at a single point. Also, a pyramid, just like a prism, is named after its base. So if the base of the pyramid, the side or the face at which the pyramid is standing, is a triangle, then it is called a triangular pyramid. That's the first one. If the base is a square, then it is called a square pyramid. And similarly, if the base is a pentagon, it is called a pentagonal pyramid. So as you see in all of these three examples of different types of pyramid, that the non-parallel edges, so it is this triangle and the one which is behind this, all of them are meeting at the single point, which is the top point. So that is what is a pyramid all about. Now in this lesson we are going to be dealing with a special type of pyramid, and that is called regular pyramid. And I'm sure the name regular is making it quite clear for all of you that how is this pyramid different from a usual pyramid. Okay, so this pyramid, regular pyramid, is having a base which is a regular polygon. Now let me remind you, a regular polygon is a polygon which has all the sides equal. So it can be a square pyramid because the base of the square pyramid is going to be square, which is definitely a regular shape. Okay, and the lateral faces are all congruent isosceles triangle, and these triangles, which are the non-parallel ones I'm talking about, the lateral faces, which are the non-base faces or non-base sides, they are going to be congruent to each other. So they'll have the same shape, they will have the same size, and the length of two sides of such a triangle is going to be equal. That's why it will be congruent isosceles triangle. So this is a special kind of pyramid, regular, that we are going to be considering in the slides to come. And finally, the third and the last term which you see on this slide is the lateral faces, and they are basically these triangles which are not the base. So they are the non-base sides that we are talking about. So these were some terms related to pyramids. Let's get to know a few more terms before we move on to the topic for today. The next term that we are going to understand, students, is altitude. And altitude, as another name, in simple words, altitude is nothing but height of a pyramid. So when I define an altitude, I have to say that it is a perpendicular segment from the vertex to the base. So let me explain it to you from this figure. So this top point from where all the non-lateral faces are meeting, this is called the vertex of the pyramid. So from the vertex to the base, so this is the base, the bottom the bottom face of the pyramid. So it looks like a rectangle here. So if you take the vertex and you join it to the center of the base, and you don't join it in any other way, you just join it in a perpendicular fashion. So you can see that this is the 90-degree angle here. So the line segment, which is the perpendicular segment from the vertex of the pyramid to the base, is the altitude. So it is marked here with this red line perpendicular. So I will just highlight here in the figure. So this is your altitude. Next we have the slant height, and let us see how is this slant height different from altitude. So slant height, first of all, is marked with the notation small l, and it is again a perpendicular segment from the vertex. So it starts from the same point as an altitude, but the difference here is that it is from the altitude, from the vertex to the side of the base, not to the base but to the side of the base. So if I take this side of the base, for example, then it starts from the vertex and it comes here down again in a perpendicular fashion to meet the side of the base, not the base but the side of the base. So this blue line, as you can now see clearly, is the slant height. So these are three important terms, vertex, altitude and slant height, that you should remember so that you can solve more questions on pyramid. And now we will just acquaint ourselves with two other different types of pyramids. One is a right pyramid, where you have uh, a pyramid who is intersecting the center of the base, whereas an oblique pyramid where the altitude does not intersect the center of the base. So you can look here in the figure. The first one is a right pyramid, and the second one is an oblique pyramid. So just in simple ways, if I have to say the difference between the two, then in the right pyramid, the angle is going to be 90 degrees. Okay, because by the name it's right. So this altitude is meeting the center of the base at a right angle. Whereas in an oblique pyramid, the angle is not 90. It can be different from 90, and that's why it's an oblique pyramid. So the altitude in an oblique pyramid does not intersect the center of the base. So with that, we have covered all the terms and the new vocabulary of this lesson related to pyramids. So let's move further now in the lesson. Okay, so that brings us now to the first key concept for the lesson, which is lateral surface area of a regular pyramid. So we are considering this regular pyramid here. So the base is going to be a regular polygon and all the non-lateral faces are meeting at the vertex. The formula is the lateral area, or the lateral surface area, capital L, is given by the formula 1 by 2 P times L, where P is the perimeter of the base and L is going to be the slant height. So all these terms now I'm sure you are clear, because we have done them in great detail in this lesson and even in the previous lesson. So let's see how we can apply this formula to compute the lateral surface area of a given regular pyramid. So this is the first example that we are going to be considering in the session today. Let me read it out for you. Find the lateral area of the square pyramid. So this pyramid, as you all can see, the image I have provided here for you, has a base which is a square, and that's why the name of the pyramid is square pyramid. You need to compute the lateral surface area, so you are going to be using the formula that was just shown to you in the last slide. And to answer this question correctly, we need two things. One is the perimeter of the base, so the perimeter of the square, and that can be easily calculated because each side of the square is equal and one side is given. So the perimeter is going to be 4 times side, so 4 times 4 centimeter, so it is going to be 16 centimeter. That is what we are going to be substituting here in the formula. And second thing that we need to put here is the value of the slant height, which is given by small l, as I explained to you when I was telling you the terms for pyramid. And that is also given to you in the question. This pink highlighted height is given as 6 centimeters. So you just have to substitute both the values, and that will simplify and give you your lateral surface area as 48. Again, the unit is very important. since these two lengths are given to you in centimeter, so the unit for the lateral surface area of this square pyramid is going to be 48 square centimeters. So that completes our first example. So let's try one more question on lateral area of a pyramid, and I want you to try this with me. If you want, you can pause the video now and just test yourself. Have you understood the concept? Have you understood the formula? Are you doing correct calculation? All of that. And as I always say in my videos, that when you're trying to solve a new question, first read it carefully, highlight what is given, what you need to find, and then after you understand, plan out your method, plan out your steps of solving. So let's read it for the first time. Find the lateral area of a regular. So we have to find lateral area. And what is this pyramid? It's a regular pyramid with hexagonal base. That's why the name hexagonal pyramid. And each length or each edge of the base is 9 inches long. So you highlight the number, and a lateral height of 7 inches. So two things are given to you. Let's first write what is given. So given base edge length is 9 inches. So this base edge length would help you to find the perimeter of this special kind of pyramid, which is a regular hexagonal pyramid. So think about a hexagonal pyramid. How many edges it is going to have? Think about it, and I'm sure you will agree that hexa means 6, so it is going to be having 6 equal edges, being a regular pyramid. So 6 times length of each side, if I take it as S, is the formula to find the perimeter. So just do the substitution. 6 times 9, and the unit is going to be same, inches. That would give you your perimeter. What else is given to you? Let's write that also. So you are given the lateral height, and that is nothing but your small l or your slant height. So you can write that value also. It is given to you 7 inches. So we have got in the question already the lateral height or the slant height. We have computed the perimeter. So let's now just substitute both of them into the formula for lateral surface area, and that would give us our correct answer. So let me write the formula for you. The lateral surface area is 1 by 2 times P times L. I'll put it in a box that you are going to be remembering it. I will be giving you few seconds. All the values are here with you. I just want you to substitute. If you want, you can pause the video and then try out this question. Let me put the value of perimeter also. So 54 inches. Let's just substitute here everything. So 1 by 2 times 54 times 7. So please simplify and tell me what you are going to get as the final answer. Remember, don't forget the units, because units are very, very important. So that would just simplify your answer. And because you're multiplying two sides which are given in the unit of inches and inches, so this unit will definitely be inches whole square. So just simplify, you are getting 27 times 7 inches, and that is your answer. Okay students, now let's do the second key concept for today, that is the total surface area of a regular pyramid. So just like prisms, it is going to be very, very similar in the sense that you are first going to be taking the lateral area, and then you'll take the area of the base. So just add them both, and that will, the sum will give you the total surface area. So the formula that you are going to be using here is S, capital S, denotes your total surface area, is equal to half times PL. P is the perimeter of the base, L is the slant height, and capital B is the area of the base. So all the things are very, very similar to the last slide. It's just that to the lateral area you are adding up the area of the base. So depending upon the kind of pyramid which is given, it can be a square pyramid, so you take the area of the square as capital B. It can be a regular hexagon as you saw in the last example. So you take the area of that hexagon as the capital B value or the area of the base. Let's apply this formula now in solving some questions which we are going to be checking in the slides to come. Okay, so this is the first example of total surface area that I'm going to be considering, which is your example 2. So find the surface area S of the pyramid. First, I want you to observe what is the shape of this pyramid. And I'm quite confident that you have identified the base here. So the base has 7 feet of length and all two sides are marked here as 7. So that means it's a square pyramid. So square pyramid, that's the regular pyramid we are talking about, and each side of this pyramid, the base of the pyramid is 7 feet long. So that will give you the value of capital B, which is going to be the area of the square. That can be easily calculated by the formula side square, that will give you 7 square or 49. So that was quite easy. Let's come to the second part of the question where we need the lateral surface area to be added to this part. So how can we find that? And if you just try and open this pyramid, it'll look like this. So this figure that you see here is the net of the pyramid. And from the net, you can easily identify that the non-base sides or the lateral edges are triangles. And for these triangles, the each length of the base is 7 feet. You can see that. And the height is 8 feet. So you can easily find the area of each of this face by putting them in the formula for area of a triangle, which is half base times height. And again, these are four congruent triangles. So you are going to multiply the area of one triangle, which was half base times height, with 4 to get the lateral area. So let's do that and let's substitute. So B, which is the base, is 7 feet long. H, which is the height of the triangle, is 8 feet long. So let's just substitute them both in half times B times H and simplify after substituting to get 4 times 28, which is 112. And now finally we are going to be adding these two areas that we have got, the base area 49 and the lateral area 112 to get 161. And I'm sure you will not forget to put the units here, and the unit for the surface area of this square pyramid is going to be feet square, since the two dimensions were given to you as 7 feet and 8 feet. So the final answer, let's sum it up. The surface area, the total surface area of the square pyramid is 161 feet square. Okay, so that brings us towards the end of the lesson today. So in the lesson, we had seen how we can find the surface area, and now it is time to test all my viewers and all my dear students. So as a part of the homework, I want you to practice this question yourself. The square pyramid is given to you. It's a regular pyramid for sure. And I want you to find the lateral surface area and finally the total surface area of this pyramid. Put your answer in the comment section so that I can check them for you, and that will test your understanding. So do try and do comment about your answer. Let's summarize the concept that we've learned today. So in this session today, we focused on regular pyramids and we found out the lateral area and the total surface area of regular pyramids. So remember the two formula that I want you to be learning so that you can use them for solving questions. The first one is capital L equal to 1 by 2p times L, where L is the lateral surface area or the lateral area. Capital P is your perimeter of the base, and L is your slant height of the pyramid. So that was about lateral surface area. Coming to total surface area, formula is denoted by capital S is equal to 1 by 2 PL, that is your lateral surface area, plus capital B, which is your base area. So just sum up the base area to the lateral surface area, and what you get is your total surface area. So thank you so much, my lovely viewers. That brings us to the end of the session. As always, I would remind you to revise today's session, and looking forward to seeing you in the next class by learning more and more about different solids. So bye students, and don't forget to like, share and subscribe to my channel. Bye bye.